Hey everybody, welcome back to another video. I'm really glad you're here. In today's video, we're looking at a very interesting expression that we need to differentiate. We have x to the x power. And I know how tempting it is, but we cannot use the power rule here because we have a variable in the exponent. You can only use the power rule when you have a constant in the exponent. For example, if we had x to the second power, x cubed, x to the fourth power, then the power will be applicable. But we're going to have to do something a bit different here. I'm just going to start by introducing a variable, which makes things easier oftentimes. I'm going to say that y is equal to x to the x power, the expression we want to differentiate. Now, as we discussed, what makes this problem a bit difficult is that we have that variable in the exponent. Well, if we can rewrite this expression so that the variable isn't in the exponent, then that might make things easier. Can you think of a way we can do that? You can take a minute to come up with some ideas. If you thought of the natural log, then you'd be correct. We're going to just take the natural log of both sides. When we do that, we get ln y is equal to ln of x to the x power. And this is useful because we know that from the properties of logarithms that we can just move this exponent out to the front. When we do that, the right side is just going to become x ln x. Okay, so we've gotten rid of the variable in the exponent, but what now? Since we're trying to differentiate, we want to find y prime, since y is x to the x. So it makes sense then that we would try to differentiate both sides to see what we can get. When we differentiate the left side, we're going to get y prime over y. This is from the chain rule. The derivative of ln x is 1 over x. So the derivative of ln y is just going to be 1 over y times the derivative of y. And then on the right side, we're going to have to use the product rule. The derivative of x is 1. So the first term is going to be 1 times ln x, which is just ln x. And the second term is going to be the derivative of ln x times x. The derivative of ln x is 1 over x, which means we're going to end up with 1 over x times x. And if we simplify the right side further, we get ln x plus 1. Y prime over y is equal to ln x plus 1 is our equation. Since we're trying to find y prime, it would make sense to rewrite this equation so that y prime is by itself on the left side. All we need to do then is just multiply both sides by y to make that happen. And when we do that, we get y prime is equal to ln x plus 1, the quantity ln x plus 1 times y. And remember, based on what we wrote at the very beginning of this problem, y is equal to x to the x. So we're just going to make that substitution back into this expression on the right side of the equation so that our derivative is only in terms of x. That means our final expression for the derivative is going to be the quantity ln x plus 1 times x to the x power. Now that we're done, I'm going to put this answer in the infamous green box. And yeah, that's it. I think this problem is interesting because you have to think outside of the box a little bit to find the answer and make some progress. It's not like a lot of other differentiation problems where you just apply the rules and get your answer. This problem also shows how powerful implicit differentiation is, which is what we used on the left side when we took the derivative of ln y. Implicit differentiation is hard to understand for a lot of people, but just like with anything in math and in life, the more you practice it and get exposure to it, the better you get at it. Anyway, that's about all I had for this video. If you have any comments, suggestions, feedback, or questions you wanted to ask me, please feel free to leave a comment. I will respond to all comments left on this video. Otherwise, have a great day, and I'll see you in the next video. Goodbye.